Hello everyone, welcome back in the lecture series of Strength of Material and myself, Dr. Irshad Ahmad Khan, Associate Professor, Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. So today topic is stresses in inclined plane. This is a very important topic, and the previous lecture we discussed about the stresses due to the normal load. And today we will discuss the stresses in inclined plane due to the load at two mutual perpendicular plane. So the two case we will discuss today. First one, the stresses in inclined plane when the load is applied at mutual perpendicular plane. Here this plane are AC and BC. And second case is the same condition. We have to calculate the stresses in this inclined plane due to the loading at this plane and this plane, you can see which is perpendicular plane, but also in the second case, there will shear stress in plane AC and BC. So these two cases we will discuss in this lecture, and definitely you will understand this important concept here. So let's start first case. So consider a small element A, B, T of thickness T. The thickness of this element, suppose this one is T. This thickness you can see, this one here. This is T. So this is T. Thickness is T. So this will also T. Okay, the whole thickness, this, and this also T thickness. So, and you can see the the plane AB makes angle theta from the BC, and AC and BC are two mutually perpendicular plane. Okay, so you can see this is this is a stress sigma x in x toward the x-axis and sigma y stress in toward the y-axis, and it's produced due to the applied load px and py. So px is a perpendicular load which is applied in plane AC, and similarly, that BC, in the BC plane, the load PY is applied. Due to these two loads, the stress is generated, uh, sigma x and sigma y. So we can resolve these force in two components. One is that parallel to the plane, inclined plane EB, another is another in direction of perpendicular to the inclined plane AB. Okay, so here you can see this is perpendicular one and in parallel to the inclined plane, and this is a perpendicular to the inclined to the two components. So this is also angle theta, you can see, because this is a parallel. This is the horizontal one, and this is a parallel to this inclined one. This making angle theta, so this will also be theta. So this become px cos theta, and this component become px sine theta. Similarly, we can resolve the force py. So this is theta. This is also uh, theta, and py making the angle theta with this perpendicular component of the BC. So you can see this become py cos theta, and this become py sin theta. This is a simple, you can see, arrangement of resolution of forces, and which is help us to be get the value of normal and shear stress on the inclined plane. So let's erase these all, what the I have written here. Hope you are understood these things. So this, if you remember this, resolution of force, so easily we can get the solution of this particular case. So here you can see the normal force acting on plane AC and normal plane acting on plane BC. So you can see the AC plane, AC plane, this one is the AC. So we can write this one sigma x into the cross section means this AC into the thickness of this, that is a T. So this will become the force which is acting on this plane. Okay, we can write Px. Similarly, the normal force acting on the plane BC. So we can write Py, Py sigma y into BC into T. This is okay. Hope you understood this normal force which is acting on it. And now we can calculate. So we can see that here the normal resisting force acting on plane AB. So plane AB you can see means this. So in this direction, you can see this direction, in this direction. So this one, this is acting Py cos the Py cos theta component, which is acting perpendicular to this plane AB, and this one other component Px sin theta. So you can see this is this direction, this is, and this is opposite of that. So we can write, so force which is acting here and P theta equal to Px sin theta plus Py cos theta. Okay. Similarly, you can see the component which is parallel to the inclined plane AB. So here, suppose I am writing here, this is called the force, shear force F theta here, and here P theta, that is a normal force. Okay, so this the direction of this one, either you take the red one or blue direction of that, or this black one also. So there nothing going to be changed. So this red dotted and blue dotted lines showing the resistance force. Okay, force of resistance. So we can take either of that. There is not going to any change on the final relation. So let's see this direction and this direction, Px cos theta, both have the same direction, and this one is the opposite direction. So one, if you write the equation, so we can write the F theta plus Px cos theta equal to Py sin theta. So Px cos theta, it goes when the next right side, so it's get the minus sign. So we can write finally, हम इसको कैसे लिख सकते हैं, you can understand that px that is Py sin theta minus Px cos theta, which is equal to F theta, F theta. So hope you are understood this concept. Let's erase all this value what I have written, and let's see that already mentioned in this PPT. Okay. Let's see. The normal resisting force acting on plane AB, that is Px sin theta plus Py cos theta. Similarly, the shear resisting force acting on the plane AB, that is, you can write PT, okay, tangential component of the force, that Py sin theta minus Px cos theta. So if the sigma theta and tau theta are the normal and shear resistive double up on the inclined plane AB, so similarly now we not need to be do the more things, just you put the value of Pn, Px and Py in this equation, this one. So we can write, this is Pn normal one. So we can write sigma theta and the cross section AB into T. You might remember that diagram. And this is we have already taken Py, and here you can see that PAC in T into sigma. Okay. Hope you're getting the point. So this because sigma x is into T, and the sign multiply by this sign plus Py, and that's value of Py BC, sigma y BC into T into cos theta. So what T is the common in the both sides, so T is cancel out, and that AB divide in the right side equation. So AC upon AB into sin theta sigma y BC upon AB cos theta. So this become AC upon AB. You remember it. This is right angle triangle. Okay, understood? You can see that A, B, and C. So here AC upon BC, AC AC upon AB. Sorry, this is a perpendicular. You might remember this is theta. So perpendicular upon hypotenuse, that is cosine. So this becomes sine square theta plus sigma y. This BC is the base upon hypotenuse, that is called cos. So it's become cos square cos square theta. Now we can sine square theta we can also write as 1 minus cos 2 theta by 2 plus sigma y, and this cos square theta we can write 1 plus cos 2 theta by 2 1 and that's just open this bracket and rewrite. So it's becomes sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta. This is a final expression for normal load which is acting on the inclined plane. If you know the value of sigma x and sigma y and angle theta, so we can calculate the normal stress acting on the plane, normal stress acting on the inclined plane. Similar, we can calculate the shear force acting on the inclined plane. Just we will put the value of pt, py and px in the second equation and we will get. So that similarly we can do. That equation is pt py sine theta minus cos x px cos theta. Just put values. This pt is tau theta into ab into t, and similarly that pt is equal to sigma y bc into t sine theta minus bx ac sine cos theta. So similarly, the t cancel out in the both side and divide by ab in the right side equation. So this bc upon ab is cos and this ac upon ac is sine. So we can see write it sine theta cos theta and sine theta cos theta. Just take the sine theta cos theta common. So it's become sigma y minus sigma x. Okay, and so sine theta cos theta we can write sine 2 theta by 2. So it can be write as sigma y minus sigma x by 2 sine 2 theta. So this is expression for find out the shear stress on inclined plane. Hope you understood this first concept. Similarly, we can get the second concept with this here. So let's discuss second one. I already told you that in this second case things are almost same, but we are applied the shear force on the two mutually perpendicular the plane. So let's discuss about this the second case. Here what happened actually, um, this is applied. So two two forces also here, and that is this 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 direction which is responsible for this shear stress, that is F, that is this F. Suppose this is F. So because it is going to Y, so we can say write as Fy, and this is moving toward the X and we can write as Fx. Hope you understood. I made this nomenclature for your understanding. So you can see what happened. So this force which is already which is responsible for px1, px here is which is responsible for this shear stress, and here py, here this is py which is responsible to for this shear stress. Sorry, normal stress. Okay, and this one is also normal stress. Okay, so direction of this px which is acting in this perpendicular top plane AC, and this force this py which is acting perpendicular to the plane BC. So here you can see this tau which is produced by Fy, and this Fy is acting uh, toward y-axis, and this fx which is responsible for this tau which is acting at plane BC, which is direction is toward x-axis. So what we have done here, so which force acting in the horizontal direction and the vertical direction we just add here. So this px and fx we have add here. and taken two component. One is the parallel and perpendicular to the inclined plane, and this angle must be theta. And similarly here, so pfy and py, which is acting in vertically, and this angle, similarly this angle is theta, resolve two component px plus fx cos theta, and here second another component is px plus fx sin theta, here py plus fy sin theta and py plus fy cos theta. But this is similar to that one, but the concept is only is shear stress, and shear stress is produced by the shear force, and that shear force you will have to be take in consider in this such manner, the horizontal and vertical direction which is force acting, just add on and take the resolution of that force. Okay, so let's understand that's this concept. First erase all these things. Okay, so let's understand. So normal force acting on plane BC, you remember plane BC is nothing but the which is y-axis one, where the sigma of py is acting. So py sigma y bc into 2. Similarly, shear force which is acting on the plane bc, that is fx, which is yfx, because it is moving toward x-axis. So tau this tau bc into t. Similarly, normal force acting on the ac, so we can write px sigma x AC into T, and similarly shear force, that is tau AC into T. The horizontal force and vertical force just add on. I already told you, and with that we have done here. And normal resisting force we can write same concept what we have done. So you can say the normal one which is acting, this is acting opposite of this is acting this one moving upward, and this is downward of this plane. So you can see this will be add on together, and which is equal to this one. And similarly, what happened, the shear force one, because this one and this one are moving same direction, so this one will minus to this force. So this is simple concept, simple. You can say um, equilibrium of equation, we can equilibrium of force concept we can apply here. So normal resisting force which is acting, P and Px plus Fx cos theta plus Py plus Fy sin theta, and tangential force or shear force component you can say P and sorry, this should be Pt. Okay, this should be Pt. Okay, so this should be Pt, and so it can be write as like this. And similarly, just put the value of Py, Fy, and px and fx in the equation number. This okay, for your better convenient, you can give the name of this 1 and 2. Okay, so let's put the value of all forces in the equation number 1. We have put all that this value here, and t is a common, cancel out and divide the right side term by the term AB. So this become BC upon AB, AC upon AB, AC upon AB, and BC upon AB. So BC upon AB, it will be cos, so this become cos sigma y cos square theta plus this is tau sin theta, this is a sine, so this becomes sin theta cos theta, and sigma x, this is a AC upon AB, and AC upon AB is sin square, plus this is a BC, so this is a cos. So, so because this is BC is a cos, and this is should be this is become sin theta. So it's become sin theta cos theta. So just put the value of that 1 plus cos 2 theta of, you can write cos square theta, you can write as 1 plus cos 2 theta by 2, and sin 1, this one you can write as sigma x 1 minus cos 2 theta, and just this two term add on 2 tau sin theta cos theta, and just open the bracket and again rewrite. So it's can be written sigma x plus sigma y 2 plus sigma y minus sigma x by 2 cos 2 theta, and this can be write as sine 2 theta. So it become tau sine 2 theta, tau sine 2 theta. So this expression for calculating the normal stress on inclined plane. Similarly, we put the all values on the second equation. That value here we put all the value. So this is can be write as t is the common and divide by AB. So the whole expression become like this. And this BC is sine, this AC is BC is cos, AC is sine, AC sine, BC cos. So again, this term can be write as and sine. This is sigma y sine theta cos theta or sigma x sine theta cos theta. So this becomes sigma y minus sigma x by 2 sine theta minus tau cos square theta minus sine square theta as cos square theta minus sine theta can be write as cos 2 theta. Okay, hope you are understood this simple concept, and this is all about the normal and shear stress on the inclined plane. Both case we discussed, and hope you are understood. So thank you so much for attending or listening this lecture. Thank you so much once again.